There's another API for working with XML data, and that's called the Document Object Model, or DOM. This API is put forward by the W3C. So there's a standard for not only the design of the API, but also an expression of the API inside the Java programming language. There are actually other language bindings for DOM. Some of you might be familiar with it, the JavaScript API for DOM. The document object model views structured hierarchical documents like XML as trees of objects. So DOM models objects as depicted in this diagram here. So here we've got our phone book XML document, and so there is a root object in the hierarchy called phone book, and then it has children objects like resident and business, and so on and so on. So you've got an object-oriented view of your XML data. And in DOM, each one of these objects is represented as a Java object, and there's an API that you can work with them. The org W3C DOM package contains a hierarchy of interfaces that specify what a DOM tree might look like and might contain. There's a root interface called node. All objects in a DOM tree are nodes, some kind of node. And then the node interface is further refined to represent more specific types of nodes, such as the document itself, or an attribute within that document, or an element. Not surprisingly, there are several refinements of character data. You can have an object that represents a comment, a text, or a CData section of your document. Let's take a tour of some of these APIs. So for node, this is the sort of fundamental class in DOM. It has methods like append child, which will add a child to that node, and you can get the name and the attributes of that node. Note that with the attributes, they're represented not with a standard Java util map. This API is pretty old and might even predate the map API. Instead, it provides its own implementation of the attribute key value pairs called named node map. Every node also refers back to its owning document and its parent node. Document not only represents the entire document, but it also provides factory methods that let you create new nodes within that document. So for each type of node, there's a factory method, so you can create an element, a text node, an attribute, and a comment. After you create the new node, you'll need to make it a child of some other node in the document. The document interface also contains methods that let you get other information about the XML document, such as its doc type, the root element, and you can also query the document for all elements that have a given name. Element represents an element in the XML document, and you can get its attributes and its tag name, and you can also set and remove them. And you can remove them either by the name of the attribute or by an attribute object itself. An attr represents an attribute of an element, and you can get its name and also set its value. And there's also that named node map interface that lets you work with all of the attributes associated with an element. As I mentioned before, there are a couple of interfaces that represent character data. The root interface of those is called character data, and there you can get the string that represents the character data. And you can also set the string and manipulate it otherwise. The text and comment subinterfaces of character data don't really add any more functionality. Instead, you can tell from the type of the object what it represents inside the XML document. Now we're going to look at how the DOM API can be used to convert an XML representation of your data into the domain objects that your program is used to working with. So continuing with our phone book example, we're going to introduce some Java classes that represent the phone book. We're going to have a class called phone book itself, and it consists of multiple phone book entries that represent an entry in that phone book. Phone book entry is an abstract class with a lot of common state that's been factored into one place, state from a resident class and a business class. Now all these objects are created from DOM objects. So what we're going to do is parse the XML file, get a DOM tree, and then traverse that DOM tree and create our domain classes like phone book and resident, and instantiate our domain classes like phone book or resident or business, appropriately based on what's there in the DOM tree. Note that to eliminate duplicate code, in my Java classes, I've refactored common code for extracting and representing address and phone book information into that superclass. I've also reused the toString method to return a string representation of the phone book, of the business, and of the resident. There is one thing I want you to note when you look at this code. To keep the example simple, I've tightly coupled the domain classes with the XML objects. This probably isn't a good pattern to follow. Generally, it's better to separate the domain objects from the code that converts them to other data formats like XML. So here's the implementation of the phonebook class. Each phonebook contains a collection of entries, and a phonebook is created from an element in an XML document. So element comes from the orgw3c DOM API. And so what do? Well, we're given that element that represents the phonebook, and then we'll extract information from it and populate the phonebook accordingly. So we'll get all the children of those root elements, and we'll iterate over them. And note that the children of an element may be objects other than element. You could have a comment in there. You could have something else. So the first thing that you want to check is to make sure that what you're dealing with is actually an element. Once we get the child element, then we look at its name to figure out what kind of child it is. And in this case, it'll either be a resident or a business. So if we find a resident, we add a new resident object created from the child element, or we create a business. I don't show it here, but if we see an element that we didn't expect, we have some options of what we can do. We could ignore it, we could log some sort of warning, or we could fail. The behavior is really dependent on how you want your application to handle unknown or unfamiliar XML data. Recall that phonebook entry is the abstract superclass of business and resident. It contains common code for representing the shared information between the two, such as the street for the address and the phone number. So in addition to having state like the streets and the address and the apartment number and all of that good stuff, it also has some shared functionality in the fill-in address method, which takes an XML DOM element as the root and populates the information in that address from that. Again, we iterate over the child nodes of that root element, and we look at the name of each element. The name of the element is street. Then we want the text information that is a child of that element. So we get the first child, and we get the node value, which is the text, the string, from that element, and add it to the collection of street lines. Similarly, if the child element is the apartment, the APT, then we get its text and set that to the apartment part of the address. So far, we've seen a couple of examples of working with elements. Here's an example of working with attributes of those elements. As you may recall, the XML representation of a phone number is an element called phone that has two attributes, area code and number. And so our fill-in phone method takes an element, which is the phone element, and then we extract the area code and phone number from that with the following. We get the attributes associated with that phone element, and then we iterate over them. And here, we look at each attribute, which itself is a node, and we look at its name, and if its name is area code, then we get the value of that attribute, assign it to area code, and do something similar for number. All of this data is string data. Then when we populate the phone field of this phonebook entry, we simply concatenate the two. Instead of iterating over the attributes of the phone element, we could have also just used the getAttribute method of element. So that's how we work with the DOM API itself. The DOM API gives us an object representation of the XML data, which we can then traverse and query and interrogate in order to get the information that we want to populate our domain objects. But we haven't seen how we obtain the DOM data in the first place. So now we're going to talk about how to parse XML data as DOM. Going back to the JavaX XML parsers package, it has factories and builders that allow you to convert XML data into DOM objects. So much like we saw with SAX parsing, this package contains classes and objects like document builder factory. It creates a document builder, and then that's the thing that has the parse methods that actually take XML from some data source, file, input source, all those other APIs. And from it, we'll create a document object, a DOM document object. Interesting to note that DOM parsers use SAX, the lower level, more memory efficient API, to do the heavy lifting, to do all the parsing. So they didn't have to rewrite a whole bunch of parsers in order to implement DOM. Instead, they take the existing efficient parsers and from it handle all of those events that come from SAX to create the DOM objects. The document builder object reuses APIs from SAX, such as entity resolver for looking up things like DTDs, and error handling for handling errors. It's another good example of code reuse. So here's some code from the main method of phonebook that uses these APIs to parse XML data and create a document object, a DOM object from it. What we're looking to create is a document object, and that's going to be our doc variable there. And inside a try-catch block, we do the following. We get a document builder factory by invoking the static new instance method. And we say we want it to be validating, meaning that when it parses the XML, it should check it for correctness and also conformity to a document type definition. Once we've configured the factory, then we invoke the new document builder method that'll return a document builder object. This is an object that parses XML and returns a DOM, and you do that by invoking its parse method. Parse method is overloaded to take multiple kinds of objects. In this case, we invoke the version that takes a file. And that will return us our document object that represents the parse XML. Of course, if anything goes wrong, an exception will be thrown and we can handle that appropriately. But once we have the document, we get its first child node, and that'll be the root element. That is the phone book element of our XML, and then we use that object to populate the phone book object and go from there. As you'll recall, we looked at those constructors. They're the ones that do all of the heavy lifting. And at the end, we print out our phone book object and our toString methods, which we really haven't seen in the lectures, but you can go check out the code online. The toString method will format it in a way that's readable by people. So when we run this code, given our phonebook.xml, does all the parsing and prints out the context in a human readable form. So those are the two addresses in the XML. So that's how you parse an existing XML document. What about going the other way? You've got some Java objects and now you want to create an XML document that represents those Java objects. Imagine that you have a program that parses in an XML file representing your phone book. And now you add a new entry to it, maybe a new residence, and now you want to be able to write it back out again to an XML file. The whole process of creating an empty DOM tree is initiated with a class called DOM implementation. This is an object that creates DOM trees, the document itself. So the create document type method will create a representation of the DTD, and there you give it the information that's in the DTD declaration. So the name of the root element, which would be phone book in this case, and the public identifier and the system identifier of the DTD. And then once you have that, you can call the create document method. That'll create a document object that is essentially empty. You can also give it information like namespace URIs. That's kind of beyond the discussion of what we're talking about here. Feel free to read about it on your own. And the way you get one of these, because remember this is in the org w3c DOM API, this is an interface. You can't instantiate one of these yourself. Instead, you rely on a factory method on document builder to get one of these objects. And note that while you're creating the DOM tree, the document object, if something goes wrong, then you'll get a DOM exception that's thrown. Now we've seen some examples of taking XML and converting them to Java objects. Then we use logic implemented in Java to do things like turn it into a human readable form or otherwise manipulate it. Oftentimes though, implementing all that stuff in Java is overkill. And so there are other ways of converting XML into the formats that you want. So just some text that's readable by people, maybe HTML to be displayed in a web browser, a different XML format, all sorts of other things. There's a standard out there called the Extensible Style Sheet Language, or XSL, for transforming XML into different formats. There are different parts of this standard. So one is called XSLT, which is a language. It's actually XML itself, so it's XML that converts XML, that allows you to transform it into some other format. A big part of the transformation is being able to refer to parts of your XML file, such as the children of an element, or find me all elements that have an attribute with a given value. All that's specified by a standard called XPath. And there's also something called flow objects, which is meant to represent a document. Think of a PDF or a Word document that has font sizes, visual layouts, tables, bold and italics, all that kind of stuff. It specifies how information flows from one page to another. That's why it's called flow objects. And so you can use these standards to do the heavy lifting of converting an XML document into a PDF, let's say. And there are APIs in Java for working with XSLT. They're all in a package called JavaX XML Transform. And like the other APIs in this package, they follow the factory pattern. So there's a transformer factory that you create and configure to create a transformer. And a transformer takes a source object and populates a result object based on it. There are sub-packages that allow you to do things like create sources and results from DOM APIs, DOM objects, and also for taking the JAXP API and creating sources and results from them. Let's say you just want to convert one XML file into a different file. You can skip all of the DOM and SAX APIs by creating sources and results directly from the stream. So for instance, there's a class called streamSource, which implements the source interface and reads its information from an input stream, from a Java I/O reader, those standard APIs themselves. Now, out of the box, a transformer just does what it's good at, converts XML into some other format. A lot of XML is only read by computers, and that's fine. They don't need to see things like white space. But if you want XML to be a little prettier, a little more approachable to a human, you can use the setOutputProperty method to control and configure various things about the transformation and how the output looks. So for instance, you can do things like specify the system ID and the public ID of the output XML. You can also tell it whether or not the output should be indented. Indented XML is a little easier to read. And also tell it what type of data should be outputted when you're transforming. And this allows the transformation mechanism to optimize and configure the transformation appropriately. So now that we've seen all these APIs, let's put them into use in an example that builds a DOM tree, basically generates XML for a phone book based on some phone book objects. So the first thing that we're going to do is get information about the DTD associated with this object. So we'll read that from the phonebook.dtd file, and we'll get its URL, and that'll be the system ID. Next, we'll use the DOM implementation API to create an empty document. So we get ourselves a document builder factory, make sure it's validating so that the XML that's generated is validated against the DTD. Then we get our document builder, and from that we get the DOM implementation that allows us to create that new XML document by calling the createDocumentType method. CreateDocumentType, give it the root name of the root element, phonebook, also the public ID and the system ID. And then once you have the doc type, you can use that to use the DOM implementation to finally create the document, the empty document that you're looking for. And you pass it the name of the root element and then also the document type object. If anything goes wrong during these processes, there are a couple of exceptions that might be thrown, like parser configuration exception and DOM exception. Now that we have our new document, we will populate it using methods from the DOM API. So the first thing we do is call getDocumentElement, which returns the root element of the document. That'll be the phonebook element. Then we create a new element with a tag of business. This will represent the business. And note that we create the element from the document object itself, and then we have to append that element to the root element to establish the parent-child relationship. We then create a name element and append that to the business. And then we create some text, in this case the name of my company, Tripwire Inc. And we call createTextNode on the document. That will create a new text node that we then append to the name. So here we're creating a bunch of elements and wiring them all together using appendChild. And then we do something similar for the address. So we append all of this information like the street, this city, the state, and the zip. These are all XML elements with a single text child. I think the most interesting example on this slide is down in the phone. Here's how we can create an element with attributes. So we go to the document and we call createElement. We append it to the parent, the business. But then we want to set the attributes. Well, we just call the setAttribute method. And then you give the name of the attribute and the value of the attribute. Once we've constructed our DOM tree using the DOM API, now we need to transform it to someplace else. We want to take that DOM representation, and in this case, we're just going to write it out to standard output as XML, as formatted XML. Here's where we use those XML transformation APIs. We're going to transform that document object and write it to standard out. And the way you do this is first create a DOM source object, a source object that is wrapped around a DOM element from the document. And then the result, the destination, will be a stream result that writes what's ever transformed to system.out. We'll use the transformer API to first get a factory. We'll create a new transformer and configure it with some information. First thing we want to say is, yes, we want the XML to be human readable, so we will indent it. It means it has new lines, it has indenting. We also want to set the system ID for the output, and then we'll call transform. And so then this will take care of a lot of the heavy lifting of generating human readable text for that XML. If anything goes wrong, a transformer exception is thrown. One of the things I probably should have pointed out on the previous slide is that when we build a document, we're working with the org-w3c DOM APIs. And those are all interfaces. Those are all very abstract representations of what's going on. And as a consumer of that API, that's fine. Of course, what's actually, if you go and look at the runtime type of those interfaces of those objects, you'll see that there is a whole class hierarchy that's provided by the implementer of the API that represents all of that stuff. But you don't need to know about that. And again, this is a good example of programming to the interface. You just care about the high-level representation, the standard representation, and then it's up to an implementer of that standard to provide the actual classes that implement the functionality. So now when we run our program, recall what it does. It goes and creates a new XML document, a new DOM document, uses the DOM APIs to populate that. That's all a Java object representation of your XML document. And then it uses the transformer API to take that DOM object, that DOM tree, and then convert it into a text-based XML, just like this. Okay, so what does all of this mean? So we've seen several APIs for modeling, constructing, and manipulating XML documents. We've seen how we can take an XML document, turn it to DOM, and we've also seen how we can turn DOM and turn it back into an XML file. And along the way, we used Java objects to represent the data in a way that's a little bit more Java-like, a little bit more germane to our application. Throughout all of this, we leveraged a document type definition, a DTD, to specify what our data looks like. And the advantage of this is that we all follow the same DTD. It doesn't matter what our programs do. We'll be able to share our data amongst ourselves without having to implement a bunch of error handling and data checking logic. And this is really the promise of XML, that you can have multiple people exchanging data using a well-understood format, and a format that can be read both by people and by machines. Now, we've covered a lot of fundamentals in this lecture, but there's more stuff that, if you're interested, you can go explore on your own. While DTDs are sufficient and they're good enough for this course, if you're serious about having well-formed and well-specified XML, I recommend that you check out XSD, the XML schema definition. This provides schemas for XML documents using an XML format itself, and it has support for much more complex and rich data types like numbers and dates. You can also put restrictions on data values, like you always have a positive integer, and you can also use things like regular expressions to validate string data. Now, the APIs that we've been dealing with in this lecture are admittedly low level. Certainly SAX is, and even DOM is kind of clunky in places. Over time, people have developed standards like JAXP, the Java API for XML binding, which is meant to streamline the amount of code that you need to write. It leverages things like Java annotations to say, hey, this field or this method represents this element or attribute inside an XML file. JAXP also has tools for doing things like generating Java classes from an XSD. So you have a specification of what your XML looks like, and you can have Java classes automatically generated for that. It even has support for transforming complex XML objects into standard JDK objects, things from the collections API like maps and lists, and also enums. And if you're doing a lot of Java programming with XML, this is something that's probably worth checking out. However, I'll warn you, my experience has been is that even though in the outset and for certain simple use cases, JAXP works really well, if you're working with complex XML, there's no way to make that simple. I've spent a lot of time trying to get JAXP to work just the way that I wanted it. It's really frustrating when I haven't been able to get it to work because just the mapping only goes so far. So I think it's good to have a good understanding of a high-level tool like JAXP and also the low-level tools like the DOM and SAX APIs. So, in summary, what have we learned? XML is a markup language that's implemented in text that can be used to represent arbitrary data. We saw lots of examples of how a DTD, a document type definition, can be used to specify the format or the schema of the XML document. And then you can use XML parsers and generators to enforce that XML has the schema that we expect. We learned about several APIs, and one of them was called the Document Object Model, which is used to model hierarchical documents as a tree of objects. And so this is a natural fit for object-oriented languages and object-oriented programming. If that's how you represent your documents, it works really well. There's an API called JAXP, which provides a standard interface for parsing XML data and working with the DOM trees that represent them. And the big thing that I hope you learned is that XML allows people to share data regardless of how their programs represent them or how it's manipulated internally.